Hello everyone. Correct descriptions of three-tier network topologies. The two correct descriptions of three-tier network topologies are, A. The distribution layer runs layer 2 and layer 3 technologies. B. The network core is designed to maintain continuous connectivity when devices fail. Explanation for people with an IT entry-level background. In a three-tier network topology, which is commonly used in larger networks, there are three distinct layers, each with specific roles. Core layer: this is the backbone of the network, handling the major data routes between different areas of the network. Its primary role is to ensure high availability and redundancy, keeping the network operational even if some devices or connections fail. This is crucial for maintaining business operations without interruption. Distribution layer: this layer acts as a mediator between the access layer and the core, implementing both layer 2, data link layer, and layer 3, network layer, technologies. This allows it to perform routing, switching, and access control functions, making it a versatile pivot point in the network architecture. Explanation for people without an IT background. Think of a three-tier network like a city's water system. Core layer: this is like the main water reservoir and primary pipelines that ensure water flows throughout the city even if one pipeline bursts. It's designed to keep the system running no matter what. Distribution layer: imagine this as the regional water station that not only stores water but also cleans it and pushes it out to different neighborhoods. These stations handle both storing the water, similar to layer 2 functions like switching, and purifying it, similar to layer 3 functions like routing.
Hello everyone. The expected outcome when an EUI64 address is generated is C. The 7th bit of the original MAC address of the interface is inverted. Explanation for people with an IT entry-level background. When generating an EUI64 address, a specific process is followed to expand the 48-bit MAC address to a 64-bit interface identifier, IID. This process involves inverting the 7th bit of the original MAC address. This bit flip is crucial as it helps in differentiating between universally and locally administered addresses, enhancing the uniqueness of the address. Additionally, the character FFFF is inserted in the middle of the MAC address to extend it from 48 bits to 64 bits, completing the formation of the EUI64 address. Explanation for people without an IT background. Imagine you have a library card number that needs to be unique so that no one else can use it. To make this number fit into a new system that requires a longer number, you change one specific digit of your existing number and add extra numbers in the middle. This is similar to what happens when an EUI64 address is generated. Part of the existing MAC address, like your library card number, is slightly altered by flipping one specific bit, and extra characters are added to make it longer and fit the new format. This ensures that each network device has a unique identifier that can be used on the internet. Hello everyone. Given the network topology in the exhibit and the requirement to add a subnet for 20 users, we need to choose the most efficient IPv4 network and subnet mask combination. Let's analyze the options provided considering the current network configuration. Analysis of options and network impact. 10.10.225.0/28 covers IP addresses from 10.10.225.0 to 10.10.225.15. 10.10.225.16/28 covers IP addresses from 10.10.225.16 to 10.10.225.31. 10.10.225.64/26 covers IP addresses from 10.10.225.64 to 10.10.225.127. We need to find a subnet that can accommodate at least 20 users and fit into the available address space without overlapping with existing subnets. Options. A 10.10.225.48/28 would cover from 10.10.225.48 to 10.10.225.63. However, it only provides 14 usable addresses, which is insufficient for 20 users. B10.10.225.32/28 would cover from 10.10.225.32 to 10.10.225.47. This also provides only 14 usable addresses, which is insufficient. C 10.10.225.48/27 would cover from 10.10.225.48 to 10.10.225.79. This provides 30 usable addresses, which is sufficient but starts at 0.48, potentially leading to address conflicts with the /26 network starting at 0.64. D 10.10.225.32/27 would cover from 10.10.225.32 to 10.10.225.63. This provides 30 usable addresses, fitting perfectly between the 0.1628 and 0.6426 networks without any overlap. Best option. D 10.10.225.32/27 is the best choice as it offers enough IP addresses, 30 usable, for 20 hosts and integrates seamlessly into the existing network layout without causing any overlaps. Explanation for different backgrounds. For people with an IT entry-level background, the selected subnet 10.10.225.32/27 provides a block of IP addresses ranging from 10.10.225.32 to 10.10.225.63. This range includes 32 addresses in total, but 2 of these, the first and last addresses, are reserved for network identification and broadcast purposes, leaving 30 usable addresses, which adequately covers the requirement for 20 users. This option utilizes the address space efficiently by fitting perfectly between existing subnets and avoiding any waste of IP addresses. For people without an IT background, think of the IP addresses like seats in a movie theater. The network is divided into sections, subnets, each with a certain number of seats, IP addresses. We need to find a section that not only has enough seats for 20 people but also doesn't overlap with other sections. Option D. 10.10.225.32/27 is like choosing a row of seats that fits perfectly between 2 already occupied rows, ensuring every seat is used efficiently and no one is left without a place to sit.
Hello everyone. The 2 accurate statements about the purpose of the OC model are: A. Defines the network functions that occur at each layer. B. Facilitates an understanding of how information travels throughout a network. Explanation for people with an IT entry-level background. The OC model is a framework used to understand and standardize the functions of a network in a layered approach. Each of the 7 layers of the OC model has distinct roles that contribute to the network's operation. Layer 1, Physical, deals with the physical transmission of data over network media. Layer 2, Data Link, manages how data packets are delivered across the physical network. Layer 3, Network, handles the routing of the data. Layer 4, Transport, ensures complete data transfer. Layer 5, Session, manages sessions between applications. Layer 6, Presentation, translates data between the network and the application. Layer 7, Application, provides networking services to the application software. This structured approach helps IT professionals understand how data is handled at each stage and troubleshoot more effectively by isolating issues within specific layers. Explanation for people without an IT background. Think of the OC model as a factory assembly line where each worker, layer, has a specific job. As a product, data, moves along the line, each worker adds something or checks the work of the previous worker before passing it along. This helps in managing the process smoothly and ensures that everyone knows their specific role. First few workers, layers 1 to 3, prepare the basic structure and ensure the product is sent to the right destination. Middle worker, layer 4, checks that all parts are correctly assembled before moving on. Last few workers, layers 5 to 7, add final details and ensure the product is presentable and ready for the customer, the end user application. This analogy helps in understanding how each layer focuses on a specific aspect of data handling, making it easier to pinpoint where a problem might occur in data transmission. Hello everyone. The component of an Ethernet frame used to notify a host that traffic is coming is C. Preamble. Explanation for people with an IT entry-level background. In Ethernet networking, the preamble is a sequence of bits used at the beginning of an Ethernet frame. This sequence consists of alternating zeros and ones and serves a crucial role in alerting the receiving system that a frame is about to begin. The preamble helps in synchronizing the receiver's timing with that of the sender, ensuring that the receiver can correctly interpret the signals it receives. This synchronization is essential for the accurate decoding of the frame that follows. Explanation for people without an IT background. Imagine you're about to start a conversation in a noisy room. Before you dive into your main point, you might tap the listener on the shoulder to get their attention and ensure they're listening. In the world of computer networking, the preamble in an Ethernet frame plays a similar role. It's like a gentle tap that signals the receiving computer to listen up because data is about to be sent. This sequence of signals prepares the receiving device to process the incoming information accurately. Hello everyone. The correct command to configure an edge router's interface to obtain a public IP address dynamically from a service provider is IP address DHCP. Explanation for people with an IT entry-level background. In networking, DHCP, Dynamic Host Configuration Protocol, is used to assign IP addresses and other network configuration parameters dynamically to each device on a network, enabling them to communicate effectively. The command IP address DHCP is used on a router's interface to configure it to automatically receive an IP address from a DHCP server, which is typically managed by the Internet Service Provider, ISP, in this context. This command is essential for devices that need to obtain an IP address without manual configuration, facilitating easy and flexible network management. Explanation for people without an IT background. Imagine you're moving into a new apartment and need to get your mail delivered there. Instead of manually telling every person who might send you mail your new address, you register with the Postal Service, and they automatically tell everyone your new address. Similarly, the IP address DHCP command on a router tells it to automatically get its own address, or IP address, from a service provider. This makes setting up internet connections more straightforward, as the router automatically gets the information it needs to connect to the internet.
Hello everyone. The destination MAC address of a broadcast frame is BFF. Explanation for people with an IT entry-level background. In Ethernet networking, a broadcast frame is a special type of frame that is intended to be received by all devices on the same local network segment. The destination MAC address used for such frames is FF. This address is recognized by network devices as a broadcast address, and when they detect this address, they know to forward the frame to all devices connected to the network. This mechanism is crucial for network operations that require sending the same data to all devices, such as when searching for a specific service or during certain types of network configuration processes. Explanation for people without an IT background. Think of the destination MAC address FF in a broadcast frame like an announcement over a loudspeaker in a shopping mall. Just as the loudspeaker's message is intended for everyone in the mall to hear, a broadcast frame with this MAC address is meant for all computers on a network to receive. This is used when the network needs to send important or general notifications to all connected devices simultaneously.
Hello everyone. The two purposes for which the Ethernet protocol uses physical addresses are A. To uniquely identify devices at layer 2E. To allow communication between different devices on the same network. Explanation for people with an IT entry-level background. In Ethernet networking, each device connected to the network has a unique physical address known as a MAC, Media Access Control, address. This address serves two primary purposes. Uniquely identifying devices at layer 2, each MAC address is unique to the network interface card, NIC, of a device, which helps in identifying each device distinctly at the data link layer, layer 2, of the OSI model. This uniqueness prevents address conflicts and ensures that data frames sent over the Ethernet are delivered to the correct hardware. Allowing communication between devices on the same network, MAC addresses are used to direct data to the correct destination within the same local network. When a frame is sent out, it contains the MAC address of the destination device, ensuring that the network switches and hubs can correctly forward the data to the right recipient on the local network. Explanation for people without an IT background. Think of the Ethernet protocol like a mail delivery system within an office building. Uniquely identifying devices, each office in the building has a unique room number. Similarly, in a network, each device has a unique MAC address. This ensures that any messages, data, sent within the network are delivered to the right office, device. Communication between devices. Just as mail carriers in an office use room numbers to deliver mail correctly, in a network, devices use MAC addresses to send information directly to the right device on the same network. This system ensures that everyone gets only their own mail, data. Correct answer, C. TCP uses checksums, acknowledgements, and retransmissions, and UDP uses checksums only. For entry-level IT professionals, TCP, Transmission Control Protocol, is designed to provide reliable communication between devices over a network. It uses a combination of techniques to ensure that data packets are delivered accurately and in order. Checksums. Both TCP and UDP use checksums to verify the integrity of data packets. A checksum is a form of redundancy check, a simple way to protect the integrity of data by detecting errors in transmitted packets. Acknowledgements. TCP requires the receiver to send back an acknowledgement for packets that have been successfully received. If the sender does not receive an acknowledgement, it assumes the packet was lost and retransmitted. Retransmissions. If a packet is lost or corrupted, TCP retransmits the packet to ensure delivery. On the other hand, UDP, User Datagram Protocol, is designed for speed and efficiency at the cost of reliability. It uses checksums. UDP also uses checksums for error checking, but unlike TCP, it does not attempt to recover from errors. If a packet is erroneous, it is simply discarded. For non-IT professionals, TCP is like sending a certified mail through the post office. You get a receipt when the mail is delivered, and if it gets lost, you send it again. This ensures that your mail reaches its destination correctly and in the right order. Checksums are like checking if the address on the mail is readable. Acknowledgements are like the recipient signing for the mail upon delivery. Retransmissions are like resending mail that was lost or damaged. UDP is like dropping a postcard in the mailbox. It's faster and uses less paper, but there's no guarantee the postcard will reach its destination. There's no way to know if it gets lost. Checksums in UDP are like a glance to ensure the address is there, but if something goes wrong during mailing, no one will try to fix it. Incorrect options explanation. Option A, incorrect because UDP does not use cyclic redundancy checks, it only uses checksums for error checking. Option B, incorrect because TCP does not use two-dimensional parity checks or cyclic redundancy checks, and UDP does not use retransmissions. Option D, incorrect because TCP does not use parity checks, and UDP does not use acknowledgements. What is the referred topic based on CCNA 200-301 study guide? What is the difference between TCP and UDP? Cisco answers IT, which is listed in the TCP/IP overview section of the CCNA 200-301 table of contents.